Face recognition. We want to match faces in images to one of the known subjects in our database. I'm using 11 classes of the publicly available dataset called CASIA Web Face dataset. First, I am splitting the data into train, validation, and test. In the first step, I am testing pre-trained models that have VGG16 and ResNet-50 architectures. Then I improve these existing models. Before going through the first step, we have to extract the part of the image that is the face. Then when predicting, VGG16 only identifies 3 out of 11, whereas ResNet identifies none of them. Then I use feature extraction, where I extract the features and labels of the images using the convolutional base of the VGG16 and ResNet-50 models. The results show that for both VGG16 and ResNet-50, the accuracy of the model remained constant through 20 epochs. In transfer learning, I'm using the convolutional base of each model to create a model on top of that and freeze the parameters of the convolution and train the parameters of the newly added layers. The results show that VGG16 adding 1 layer or 2 layer validation accuracy is 94%, whereas ResNet-50's accuracy improves significantly when 2 layers are added, from 76% to 94%. In fine-tuning, I only unfreeze the parameters of all layers in the last convolutional base, and I retrained them with the added dense layer and classifier layer. The results show that both models' accuracy improved with fine-tuning, with ResNet having greater improvement. Here is an illustration. Only ResNet-50 with 1 layer has 1 mistake. Here I'm using images with multiple faces, and those faces not in database are assigned to some class in the database. Now we want to add another person to our database. In that case, I want to repurpose the FaceNet model that's retrained on MS-Celeb 1 million dataset. In here, we see that the repurposed FaceNet model has correctly identified all the people in our database, in our images, and those not in our database.